Hi, this is MegaSplat Development Log 16. So today I'm going to be talking about some experimental features I'm working on that I'm going to hopefully ship a beta of pretty soon, as well as some other features that have been added to the project. So some of the things coming up are the ability to transfer paint jobs from one mesh to another, which is very useful if you need to retopologize a mesh. A bunch of fixes to everything from cluster noise to some shader fixes and other stuff, which has been sort of documented on the forum as usual. But the main thing, a few weeks ago, I posted a little teaser of this, but I've been working on it a lot lately. It's been pretty fun, and so I want to show it off. If you watched the last development log, you would have seen some runtime procedural texturing that I added to the product. Basically, if you're familiar with triplanar texture projection, it's a very common technique that people use that allows them to project a texture from the bottom, the top, and the side. So I created a version of that from MegaSplat that sort of takes that to the next level, lets you blend up to 18 textures with 2 different layered projections using noise and stuff. And so that's all pretty cool. But I wanted to take the sort of control aspects of this even further and produce sort of a high-end tool for procedural texturing. So what I've done is I've created essentially a shader graph. It's a very sort of domain-specific shader graph. The domain being, in this case, texturing large landscapes with MegaSplat. And so if you've worked with shader graphs, a lot of this will be familiar. You have a root node, which everything goes into. In this case, the root node has a top layer, which takes a texture index, a bottom layer, which takes a texture index, and then a blend factor between those 2 layers. That is the sort of raw MegaSplat format. When you see a MegaSplat terrain, you're looking at any given point at 2 textures with a blend factor between them, and then it's blending that across the triangle or across the pixel if you're on a Unity terrain. So basically our inputs, instead of being the normal shader graph inputs, are what texture do we want on each layer and what's the blend factor between them. And this may change a lot before you get to it, or maybe it's shipped and it's changed a lot after that. But you know, I think the basics will stay the same. So right now it takes the texture array and the texture list. I'll probably condense this to take just one thing at some point. So let's see what we can do with this. Basically what we can do is we can add a texture index. And I'm going to start by just making a texture cluster. You'll notice there's already a texture cluster thing in here. But let me just go ahead and create 2 of these. Another texture index here. And we can set this to like... Nope, why do you keep doing this stuff in? Set this up so that basically we have this texture on the top layer and this texture on the bottom layer. And then we want to blend, so I'm just going to use the height as a simple thing. So let's blend between these 2 textures over the height of the terrain. So what we have to do is we have to tell it what we want to texture. So we select our meshes, and then what we do is we do prepare selection here, and then this puts this stuff into a selection list which says these are the things we're going to work on. It'll find anything with a vertex instance stream, and at some point I'll add terrain support to this. It should be fairly straightforward, and you'll be able to select terrains as well. And then you can just treat both of them as if they're things in this selection list. So when you hit that, it actually prepares some data about these things for texturing. And then if I hit compile here, that will actually compile the shader. And then you can see it has textured everything in our scene by just tiling this shader, and we're blending between this texture and this other texture on top, right, based on the height. So that's pretty cool. We can actually change this, and if we change one of these parameters, you can see it all updates in real time. So my goal for this is to get everything to happen in real time, which is a little tricky. And also to not use any sort of compute shaders or modern things like that. So this is MegaSplat, and in MegaSplat we never really work with individual textures because we have so many textures to choose from. We want to do better than that. So I'm going to show you how to build a texture cluster And then I'm going to actually show you how to just select one. But actually learning how to build it is pretty cool because it shows you the power of this graph. So what I'm going to do here is I'm going to duplicate this node a couple times. And I used to do an asset refresh there that I think I can probably get rid of, but we don't have that pause. Let's see here, another texture index. Just duplicated that one. So now we have, in this case, 3 textures. And let me go ahead and just set these 3 textures. And actually, let me just set up them as, I don't know, something somewhat similar. All right, there we go. So we have 2 moss textures and one of, this looks like one of the rocky grass one. And then what we're going to do is we actually want to randomly select these based on something. So in this shader graph, I have a thing called a selector. And if I go here and make a selector 3, what that says is select from these 3 things based on something. In this case, it's a 0 to 1 value. So we can cook these up. Now we can say select from these 3 textures. And then we have this mid and max range, which if you watch the previous tutorial I did on the real-time texturing, that used sort of the same thing to control the angles, for instance. But in this case, we're going to build a texture cluster. So what we're going to do, and don't mind my rabbits running around getting crazy, let's create a noise 3D. And what this is a 3-dimensional procedural noise based on either world space or local space. And so we're going to plug this into our selector. And so what we're saying here is we're going to produce a noise value based on where we are in the world. And then depending on what that value is, it'll be a 0 to 1 value. If that value is less than 0.33, then we're going to choose the first texture. If it's between 0.33 and 0.66, we're going to choose the middle texture. And if it's above 0.66, we're going to choose the third texture there, texture 2. And then what we're going to do is let's just put that into our bottom layer here. And we can go ahead and compile. It will compile, and here we go. So what we have here now is that we have this texture cluster, and you can see here that based on this noise, it's choosing these different patches of this grass. And then it's blending into this other texture, you know, again, based on the height. So that is essentially what a texture cluster is. When you make these on the CPU and you use the painter, it's doing this, and I've just moved that code to the GPU, generating a noise. It's actually a 3-octave noise. And then you can actually come in here and you can adjust like your cluster scale, and you can see it all adjust in real time. And you'll notice that there's like the shader basically like goes through the objects and sort of slowly updates things in the background. Well, not slowly, it's usually done within a split second. So if I do 3, you can see a little delay between them as it updates the rock in the distance there just a little bit later. So that just is what I needed to do to keep it really smooth on when you have like lots and lots of these meshes. So this is a lot to set up, but what's cool about this is that it gives you an idea of how you can select between different things. Instead of using the noise to select, for instance, what I could do is use the angle, normal angle here, or the height. Those are kind of the 3 input factors I have right now. In some point I want to add cavity, but for that I'll have to do some pre-processing to generate the data. So now we're doing it based on normal angle, which basically means if we're pointing down, we're going to be texture 0, texture 1 and texture 2 based on the direction of the normal. I can compile, it will go ahead and apply that, and we'll see that now it's choosing these textures based on normal angle, which over here you can see on this rock, we're choosing different textures depending on which angle we're facing. So let's get rid of all this because there's a nicer way to do this. So if you've been using MegaSplat at all for a while, you probably already have a bunch of texture clusters. And so for that, you can just say, hey, use a texture cluster. And then what it'll do is it'll create a texture cluster node, and I can select which texture cluster I want here. It's uncompiling. I can plug this into, say, the top layer, and I can go ahead and create another one. And plug that into the bottom layer. Hit compile to compile the shader. Once you there's sort of two parts of this. There's the parameters, which you can adjust in real time, and then there's the actual shader, which it has to invoke the Unity shader compiler for. So now we see it's using the texture clusters that I specified in the configuration file of the texture cluster, which is really nice because it means that we can just use the clusters that we've already spent time making. And again, everything updates, in nearly real time. And you'll notice that this node has a noise input. So it's a little bit of an optimization. You can actually create your noise node and plug it into here rather than using the data that's specified here. There is some possibility that I will allow in some point in the future you to export these shaders as things you could use in the runtime of MegaSplat. But for now, I'm just going to focus on this sort of procedural texturing workflow. So yeah, so here we go. We have two texture clusters being blended over the train based on height. It's not that interesting yet, but the nice thing about this is we can keep building this out. So our height value here, we might decide that we want a little bit of a better control on it. We just don't want it to go from 0 to 1 just linearly. We want to sort of like push it all down towards the bottom. So I can add a curve, and I can plug the curve in here instead. And by default, this is just doing what it does. But if I add a point to the curve here, and that will cause it to compile the shader because the shader needs to update, I can then pull that point around, and you can see the texturing update in real time, biasing this terrain. Of course, it'd be better if I was back here. And so you can see how changing this height curve, it just updates that right away, and you can see it sort of working those tasks in the background. So this is really cool because it's very, very fast to work with. So let's actually look at making something look good, okay? We have these two texture clusters. We're painting our whole train with them. But like I said before, we can use as many texture clusters as we want. We can use as many textures as we want, as many noise functions and angles and things like that. So we might, for instance, let's create a selector 2 here. And this is basically just choose between two things based on some value. Plug that guy into there. Oops. There we go. Plug this into the top. And then we will create a noise function. CD. Let's go ahead and plug that into our selection here. And for now, I'm going to delete this height blend, and I'm just going to plug in 0 for now. So basically, I'm just going to work on the bottom layer first. And I generally like to do this with procedural texturing because it gives you a much nicer sense of everything. There we go. So what are we saying here? We're saying we have these two texture clusters. They're going to use the noise to figure out which of the textures inside of them they're going to actually use. And then we're going to feed that into the texture selector. And we're going to use another noise function to actually determine which of these two textures we're going to use. And we're just going to put that right on the bottom layer for now. Let's go ahead and compile that. And here we go. We see we have now started creating this sort of noise function with these two materials being spread over, so we get these sort of patches of whichever texture we want. Again, we can update it all. We can sort of play with the noise function as well. What is that texture I like? There we go. We can play with the noise frequency here. So if we change the frequency. We're going to get bigger patches. You can get smaller patches by increasing the frequency. And so you can start to blend this bottom layer together just based on noise. Maybe I want to do that with a grass texture instead. Oops, I want grass and I want moss. There's moss. All right, so now we're starting to get a more complex material going, where we have bits of grass and moss all growing together, which is starting to look decent. I think the noise is probably a little high frequency for my taste. Again, this is just on the bottom layer. We can get much more complex with this. We could start using things like angle, which is a nice way to do it. So this might be what we want for the top, right? So we might only want this for flat surfaces, and what we want on the side is something completely different. So let's set that up. What we can do here is add a texture cluster for our side. And for this one, I'm going to choose that rocky. You can also zoom in on this graph. It's a nice way to see the previews a little bit. Oh, that actually, this one might be nice to mix in the flats. But let's go for, there it is, the rock cliff. So let's put this on the sides. So we have two texture clusters being mixed by noise to create our sort of base flat surface. And then for the sides, we want to put this texture cluster here. So let's go ahead and add another selector too. And what we're going to do is say that, and I'll probably get these reversed the first time, that this is going to be the side and bottom texture below a certain angle. And what we're going to do is use the normal angle to decide which texture cluster to apply. So put that in here. And let's just go ahead and pipe that into the bottom layer. Again, we're only using one layer. We'll get to using multiple layers to make this look a lot better in a moment. Okay, I've got my inputs reversed. What I really want is I want these here. I should probably have a little normal flip thing here to make that easy. And, okay, so now what we can do is play with this midpoint. Now, we're not really doing a triplanar projection here. We're doing just just based on the normal angle. 0.5 is going to be effectively sideways. So if I go to 0.7, that might be a little high. It's starting to put it up on the cliff surfaces, right? I'm starting to get some of this stuff blending in. Maybe go 7, 8's too much. Probably like 6, 7 or so. 6, 8. Yeah, there we go. So here we see we now get some rocks on the sides. And I'm going to go actually just lower my contrast on this a little bit. I'll open up the inspector. A little cramped for screen size on the laptop here. Inspector. I hardly ever close the inspector. All right, so let's just look at our material really quick. I think I have my interpolation contrast way up, which is a little crazy. All right, that's a little better. I really wanted to use the per texture stuff and really clean it all up, but now I think that's pretty good. All right, so here we go. We have a nice base coat over this. We could continue to make that better. We could continue to add stuff. Maybe we add some snow based on height or something like this. We can go as deep as we want. Again, this is only using one layer. If you're using a single layer shader, this could be used. But let's go further. Let's actually use the other layer now. So to review, we're mixing these two texture clusters, which are three textures each, I think. We're using a noise function to decide which one to use. And then here we're using a noise function to choose this texture cluster, and we're putting that only on the slopes by using the selector to filter that. And that's going into our bottom layer. So let's make a top layer. Let's, for just make something kind of stupid, we're gonna, I guess we'll do it as selector 3. And I'll just mix 3 texture clusters together of sort of arbitrary terrains. Here's a texture cluster. Another one. Should really figure out why it keeps bringing that up. Lovely beta software. There we go. Okay, so I got 3 texture clusters. I'm going to go ahead, plug them in, and I could use this noise function again, or I could use a different one. Let me just make a new one. Why not? The nice thing about having multiple noises, you can change the frequencies. This would only really be something that you'd want to, optimize if you were doing this shader for something that was going to run in real time. I should want to do like, all right. So we're going to plug the noise in. So you notice the ports are colored. I'm not sure what colors I'm going to use in the final thing, but essentially right now floats are gray and textures are red. So basically what we're doing here is we're going to choose between these 3 texture clusters based on this noise value. We're going to give them equal share. And I'm going to do a couple different surfaces here. I love the shore sand. It's my favorite. Maybe a little of this. Maybe, is that grassy? This one, yeah. All right, so we're going to just choose between these based on noise. And then what we're going to do is put that into the top layer. And our blend is still 0, so we won't see it. But what we're going to do is just make another noise function. 3D noise function. And we're going to plug that in instead of 0. And then compile. Now what we see is that we have the bottom texturing blending into this top texturing, which has all these sort of random terrains in it. It looks okay. It's very random right now. So what we want to do is add some rules that will give that some rules about when this should happen. And I'm going to go ahead and make that based on height, I think. And the noise is nice because with the noise we can sort of create patches and stuff of this sort of coming in. Let me make a wider noise maybe. Yeah, big patches of stuff, probably good. So then we're going to take our height. And these are, again, the normal and height are all represented as 0 to 1 values. The noise comes out of the 0 to 1 value. So if we just multiply these together, then essentially what's going to happen is the blend factor will be the highest at the top of the terrain. Maybe that's not what we want, but let's just give it a shot. Plug it in, compile it. So now what we see is our lowland doesn't have any of these details, and our highland should have some of them blending in. But I think we kind of want to reverse that. I think what we really want is to dirty up the lowland with stuff and leave the highland as sort of grass and stuff that's untouched. So to do that, we can just 1 minus this node. So if you're not familiar with Shader graphs, 1 minus is literally just 1 minus whatever your value coming in is, which if you have a 0 to 1 value and you 1 minus it, inverts it. So we will just get height minus, or 1 minus height, which is just an inverted height. And we plug that in, compile. And now we see that this starts to appear just on the bottom. But I have a feeling we might want to control that a little more to decide where this should happen and where it shouldn't. So let's try controlling that with a curve. So we could do that. We could actually do the 1 minus in the curve, but for sort of sanity, we won't. And we can also, right now we're multiplying by the noise. Maybe we want to do it after the noise. Sort of depends on what we want to do, but let's just put the remap in. So what this does is create a curve. And the curve lets us remap this data. Given a 0 to 1 value, what do we want it to be? So let's compile this. Once it's compiled, all the parameters can be adjusted. So if we open this, and we click on this, and we pull this down, we can see that we can blend this out and control. Basically, if we have a value of 0.5, and here let's just do this, 0.5, it's going to be about 0.25, and only if we have a value of 1 will it really actually be fully 1. So this lets us basically remap the height to a curve or to any arbitrary data we want to control where that stuff blends in. So maybe what we want to do is push it up so that if you have a low value, you get this. But if you have a high value, you don't. Maybe I want to make these. Yeah. Now we can just kind of bring it up. You can see how you're bringing in the threshold here. Only appear in the lowlands. And so now we get these little bits of strewn rocks appearing on little bits of this, I don't know what to call this grass, this like mossy grass, dirty grass, whatever. Just kind of appearing in the bottom here. As we get up to the top, it stays pristine. Actually, do I have this reversed? I see them appearing here. Oh, my curve mapping is probably doing it. Yeah. So that just flattens the max so that they will never fully come in, which is kind of nice because you always get this blending of rocks into the current surface. And then up here it should be pristine, right? Yeah, okay, good. So you can spend hours playing with this. The major things I want to work on is basically getting all of this to run, have this real-time response. I think there's still a few more things I can do to speed that up before I release it. Getting it to work with terrains, which shouldn't actually be that hard. Where's the keys on this? But the nice thing about this is that you can build up these networks, and again, you can expand this to get as complex or as simple as you want. And if you're familiar with shader graphs, then the types of math and remapping you do will be very familiar here. If you're not familiar with shader graphs, so this might be a bit over your head, but you could probably figure out how to play with it and actually get something decent. But the nice thing is once you get this set up, right, I can just throw things in the world and texture them. I don't have to paint everything, or I could just use this as a base coat, because once this is burned into the vertices, right, I can still select this thing and paint on it to create, to create an exact look. So basically this has no runtime cost because it's just burning into the vertices. Now the tech behind this is kind of neat. So if you've done texturing and stuff like that, and you've had to loop through this many points, another thing I think I need to do is actually use a better hashing algorithm on the noise because it's producing these blocky artifacts, and that's coming from the 3D noise. So I'll use a better 3D noise. I chose an extremely fast one at first, but I should probably choose a better quality one, I think. Because at first I thought the shader speed was going to be a problem, but it's not. Anyway, so this is kind of a neat trick, the way this works. So you have your normal shader graph. What it does is compile a special shader function. Again, the idea is that maybe the shader function will be something that you can then plug into MegaSplat as like a real-time texturing thing, but I'm not sure about that. But it generates a shader function that will take a set of positions, like world space positions and normals and things like that, and convert that into MegaSplat texturing. And so what I do is when you press this prepare selection and you select a bunch of things, it actually goes through and it builds up a texture with all the positions of all the verts and all the normals in both world and local space burned into these textures. Then now you have, if you have, in this case I have about 120,000 vertices, so I have 120,000 pixels, which is not really that many pixels compared to a screen. And then it basically just blitz those, it sets the positions and stuff, and it just blitz the material to an output buffer, and the output buffer is essentially the MegaSplat texturing information, which is what you see stored in the control textures on the terrain. And then I basically just map that back to the vertices, but again, for terrains, it can just go directly into the map. So again, the nice thing about this is I can do the texturing incredibly fast. I don't need compute shaders. I don't need to run only on PCs or any of the other problems that these texturing tools often have, or I don't need to wait for 20 seconds to change a parameter, because again, I can just come in here and change things and watch them change. And they will update pretty quick. When I did not, so originally I didn't amortize the update, I just updated everything in real time. But then basically some of these controls got really laggy. You would hit a button and then it would be, a few seconds before Unity was like ready to go again. So now it actually just amortizes these over several frames, and you'll see the update happen a few seconds later. So yeah, that's procedural texturing. I have a bunch more work to do on this, but hopefully it will ship soon. I should quickly go over some of the stuff that's been done in the meantime with MegaSplat. So I'm going to close my little node window here. By node window. Make my inspector a normal size. Now let's say I had painted all this and I realized like, oh crap, I left a triangle out and there's a hole. And I need to like go fix the model. This is a real problem with MegaSplat. It's a real problem with vertex painters in general, because chances are you're not saving into FBX or whatever your 3D program is outputting, so you go update your model and then it loses all your data. That's no fun. Luckily, most of the time, like especially with these types of techniques, the texturing is very, very fast to do. But sometimes you really do want to save what you've done. So, let me show you how to do that. If your terrain, in this case, works with render baking. So the requirements for render baking are that your objects have UVs laid out in 0 to 1 space and don't overlap UVs. That's because what it's going to do is render out these textures from it, but if it's going to use the UV space to map back to the texture, so if you have overlapping UVs, then it's going to render those pixels multiple times, and you're going to get whichever one was last. All right, so to do render baking, you go to whichever painter tool you're using. I'm going to do this with the mesh one, obviously, because it's about meshes. You you wouldn't need this if you were on a terrain because you have a texture already with everything. And I'm just going to go ahead and select this in case I need it later. Okay, so we go to the utility panel, and there's a new option in the render baking here. So we have to set the output path first, and I'm just going to just drop it in the base thing there. It's fine. You choose a resolution for meshes. 1024 is generally going to be fine. Unity craps out at 65,000 vertices, so chances are 1024 texture is going to be more than enough. In this case, we actually have 4 meshes, but we're going to, instead of outputting like albedo or normal like we normally would, we're going to output the actual splat data. And we're just going to say export selected. We have our 4 terrains selected. Export selected. This is going to render bake these 4 terrains. Now, one thing to note is that these 4 terrains, they use a 0 to 1 UV space in total. Okay, if these were each a 0 to 1 UV space, I'd have to render bake them out individually to separate textures, right? So if we go over to the project folder and I look at that texture, where did I put it? Oh, I put it outside of the project folder. It's not in assets, is that correct? Yes, I did. Let's do that inside because that will be a little bit easier to deal with. All right, let's see if we did that not update. MegaSplat. And we're going to go into assets, and I'm just going to put it into my test. Oh, not that one. That's my shader testing. Here we go. Why is that not showing up? Just because I'm selected there? Yeah, there we go. Unity editor is a little funky sometimes with that stuff. Okay, so we export it. It's going to import it, and now we go to our folder there. Not ready. And we have, I should put it in a folder without so much crap in it. Train splat data. There we go. So here's the texture at output. And basically, the blue is if you're familiar with the texture format, the blue is basically where the blend values, and then the red and green channels are which indexes are used. So what we have to do is we have to change this so that it uses a clamp wrap mode. That's so that when you're on this pixel, you're not reading from this one as well. We want to change it to point sample. And that's so that we just get the pixel of the current value and doesn't try to blend between pixels, because that will blend your texture choices, which you don't want. We definitely don't want it compressed, because if it's compressed, we're going to have a problem with it changing stuff due to the compression artifacts. And we have to change it to advanced, and we have to turn off the bitmaps because we're not going to use them. And more, because the bitmaps are going to average stuff. Again, we don't want any averaging because that's going to break things. And then we have to bypass the sRGB sampler. So if you're in Unity 5.5, this is a little different. It has a linear checkbox, which is much easier to understand. But basically, we want the texture linear, which means that this is data, it's not color, so don't gamma correct it for display on monitors. So that sets up the texture for us. Now, let's just go fill this with a cluster here. And now we've lost our paint job, right? Did I not have it selected? Oh, there we go. So, oh no, we lost our paint job here. We didn't seem to fill them all. Fill? There we go. We want to get it back. So now what we can do is get it back from that data that we exported. And so if I was changing my mesh, I could go in, fix up my mesh, get a new one, run it through this splat converter again, because again, it's got to be in MegaSplat format. And then we can use this splat data to vertex data. And then we can just grab our splat map here. We can use the source UVs, which is what we baked it out with. And then let's just go ahead and bake it. And there's our paint job. Right back again, just like we left it. So, you know, if you have to go edit a mesh, and again, your mesh is a train or something like that that's laid out in 0 to 1 space with no overlaps, this will allow you to save off your texturing and then get it back. Now, some people asked about, like, hey, could we transfer this to LODs? You could. The thing with that is there's two things. One, you can use it to transfer it to a lower detail model. It would not line up exactly perfectly because, again, it's going to end up with less control points, and therefore the blending is going to end up a little different. But you could do that. The other thing that you can do with the render baker is actually bake out a diffuse and normal map, etc., and then just turn it into a regular shader. So you know, there's a memory trade-off there between having a model that just has some vertex data on it versus having a unique texture for that object. But that will produce a better LOD in the distance because it will look exactly right. So yeah, let's see what else is on the 1.05 list here. So I talked about this way to transfer data with these two new tools, which is pretty awesome. Add an option for puddle raindrops so that it'll use the dot product of the normal and the up vector to determine where puddles should go, so that so that where raindrops will fall. So you don't get raindrops on walls. Some people paint water onto walls for caves and things, and then if you turn on raindrops, it rains on them, and that doesn't look very good. I fixed a bunch of stuff when you were converting in 1.04. Something I may have been broken before this, but when you convert from Unity trains, it wasn't using the texture clusters correctly, and so it would end up choosing the same texture over and over, which was really sad. There was a brush target value for when you're brushing, so that you can actually say, like, hey, don't fully go to this texture, just like stop halfway. That wasn't exposed. I don't know what happened to that, but I fixed it. And it turned out that when you're in normal SAO mode, it still uses the metallic slider for your base metallic value, but it didn't show you that slider. So I think there were some people who would have shiny trains and be like, hey, how come it's shiny? And it's because your metal was set to 0.5 from when you were messing around with another packing mode. And now that you know, you're switched in this packing mode, you couldn't undo that and set it to 0. So fix that so that now that shows. I cleaned up some warnings in 5.5. There's another warning I've been meaning to clean up forever that I should do before I release. But less warnings is good. Hopefully this one will get rid of all of them. And then there was a shader compile error in some of the combinations of procedural texturing when you're using runtime mesh preprocessing. So that is now fixed. So yeah, so I am looking to release on, or rather submit to the asset store this Monday. So hopefully I can get this procedural texturing in a sort of a beta version that people can play with a few of the improvements. And then I can get some feedback on it from you guys, and what kind of nodes you'd like to see and things like that. Really quick, let me just go through the nodes if you're still watching, if anybody's still watching. I don't know how many people actually watch these things, but MegaSplat text graph. So nodes that I have right now, again, there are only two types. There's the texture indices and then float values. So this is a very simple domain-specific shader graph. You can add a float value if you just need a constant value. Under math, you can abs that value, you can add, you can clamp, you can divide, you can lerp, you can take the min or the max of two values, you can multiply two values, you can do a 1 minus. You can pow a value, which is a cheap way to get a curve. You can use an actual remap curve or subtract. The remap curves are actually neat. They generate little textures that go into a texture array that are used in the shader so that it can do the curves. I actually have a thing on my GitHub if you ever need a way to have a curve that you specify to a shader. There's a tool on my GitHub that lets you, I think it's called curve material or something, and lets you have curves in your material editor that you can use that really just drive textures. It's the same technique, pretty cool. For the MegaSplat stuff, I might change all this layout. You have the main output node, which is created for you. You have your height, which is a 0 to 1 for the bottom of your selection. And again, it takes that whole selection of things you're texturing into account. So from the bottom of that to the top is a 0 to 1. Noise 3D, which will create a 3-octave FBM noise. I'll probably add some more options to that because good quality noise is a beautiful thing. Normal angle, which is, right now it's normal angle versus the up vector, but I will probably expand this so it's against whatever vector you want. So if you can want to, filter things basically that are, based on some angle of the sun or something like that, you could do that. Selector 2, 3, and 4, which are basically select between two texture choices. 3 texture choices or 4 texture choices based on some float value. Again, those have adjustable ranges, and you can plug noise into them and things like that, so you can get really weird and wacky. A texture cluster and a texture index. A texture index is a single texture. A texture cluster is basically a noise function, and the texture clusters that are built on the regular MegaSplat imported in for you to use. And yeah, I think that's pretty much it. If you play with this, just remember you need to select some objects, you need to prepare selection, and this will tell you which objects you're working on. And then when you finish making changes to the graph layout, you can compile, but it will actually compile, at least right now, anytime you change any of the values anyway, it will make sure that the shader is compiled. Yeah, hopefully this is useful. It's really early. I think there's a lot of things I can do to make it cooler, but let me know what you need and what you think. And thanks for watching.